Hello guys, welcome to my new channel Study Hub. Today I will discuss the part 3 chapter of modern periodic tables. In the previous two classes I have already discussed part 1 and part 2 of periodic tables. Those who have not seen or have not understood, go to my description box, link is there, follow it. Today's discussions is, the first one is about the SPDF block. I have already discussed SP and D. Today I will discuss the first topic, A block elements, characteristics. Then the position of hydrogen and helium, that is the anomalous of SPDF classifications. In this context, I have to discuss about the position of hydrogen and helium, which is not satisfied the table. Next, the board's classifications on basis of electronic configurations. And next, lanthanide contractions and also actinide contractions. And the last of all, I also again discuss about the position of elements in periodic table, that is a long form of periodic tables. You have to find out in which group or in which period an element is situated. This last topic I have already discussed in my yesterday class. Today I also discuss for your better convenience. Okay? So come, I will discuss. So I am discussing about the A block elements. There are total full blocks, S blocks, group 1 and 2. This is the P blocks, 13 to 18, and 3 to 12. This is the B blocks and A blocks elements. These are 6 and 7 periods. And this exists in the group 3 elements. See, in the group 3, see out here, 57 to 71. Lanthanides are lanthanum to lutetium and actinides to lawrencium, 89 to 103. There are total 15, that is including lanthanums and including actiniums. That is 14 elements are there in this period, both 6 and 7. And third group, 6th period, third group, 7th period, third group. Both these group, 14 elements already included at a core. So these elements are arranged in the lower of the periodic tables. This is known as the A block elements. This is the A block elements. These A block elements starting from selenium 58 to lutetium 71, and the 7th load from the actinium, that is thorium 90 to lawrencium 103. These 14 and 14 elements are situated at the below of the periodic tables, which is known as A block elements. These elements, the electronic configuration of these elements. Each element has electronic configuration. I have already discussed about the S block element configuration, D block configuration, P block configuration. I have already discussed you. A ब्लॉक जो एलिमेंट है उसका जो कॉन्फ़िगरेशन होगा, कॉन्फ़िगरेशन क्या होगा, उसका फॉर्मूला हो NS1 NS2 N-2F N-1D. Outermost cell this, then this, and this is the innermost cell. This is the innermost cell of F. Okay, this is the A block elements. NS2, N-2F, N-1D. This is the electronic configuration of the A block elements. You can easily configure any elements in A block elements. The main characteristics of these elements, see, most of the radioactive elements, transuranium elements, this is the radioactive elements. Mostly this is the metals also. Okay, so and all other property when I will discuss about the next topic, the Board's classifications. Here the So next come the part 2, anomalies of SPDF classifications. In SPDF classifications, what are the anomalies are there? What you see in the periodic tables, there are 4 blocks SPDF. Within these 4 blocks, all the elements in the long form of periodic tables have been arranged properly. But the position of hydrogen and position of helium, there is some problem. There's anomalies of position of hydrogen. It creates a problem. Why? What we see, the position of hydrogen and the helium, what is the electronic configuration of hydrogen? Hydrogen electronic configuration 1 S1 and helium 1 S2. So both elements, both electrons in the outermost cells should be, and this hydrogen and helium, both the elements should be kept S block, and last electron goes to S block. Okay? Yes, what we discussed earlier, last electron goes S orbital, so both of these should be S block. But what we see, helium is placed where? In the 18, that is the P block elements, that is the along with noble gases here, and hydrogen S blocks, but it is just cannot be placed in group 1. Why not? It has similarity and properties to what? It has unique behavior like halogens and also with alkali metals. Hydrogen have both the property with along with similar property with the alkali metals and also with halogen groups, chlorine, bromine, iodine. So hydrogen should be placed either here or there. In some of the tables you can see hydrogen is placed in the top of the periodic table, not here, not there. So this is the anomalies of the SPDF group classifications. Helium will be there, but helium is there because helium has a similarity with the noble gases. So it is placed at the top of the periodic table. This is the anomalies of hydrogen and helium. Okay? So next come the Bohr's classification on basis of electronic configurations. Bohr's classification on basis of electronic configuration. So what you see out here, total elements are classified in 4 blocks, SPDF blocks is there. Okay, so but Bohr scientist, he classified all the elements according to their electronic classifications by electronic configurations. Okay, what he observed that according to the classifications of the electrons configuration, the S block, D block, P block and A block elements, he classified the total elements in 4 groups. What is? One is the representative elements, number 2 is transition element, number 3 is inert transition elements and noble gases. The representative elements, transition elements, inert transition elements and noble gases. Transition elements, representative elements, this and this, S block and P block. Transition elements, D block elements, inert transition elements, this is the A block elements, and noble gases, the right corner, most right corner, that is the 18 group elements, It is known as noble gas or inert gas elements. Okay. So what is the features of the elements? Proof S block elements and P block elements. The S block elements, see, in S block elements, what we see in S block elements configuration NS for S block element के लिए configuration क्या है? NS 1 to 2. See, that is, these are known as the representative elements. Any element, sodium, potassium, calcium, rubidium, cesium, what you see, the last cell, last electron goes to s orbitals. See, sodium 1s2, 2s2, sodium इलेक्ट्रॉन कॉन्फ़िगरेशन कितना होगा बोलो? 2p6, 2, 4, 6, 10, then 3s1, ns1 to 2. Group 1 and group 2. That's a group 1 में s का s ऑर्बिटल में 1 इलेक्ट्रॉन, group 2 s ऑर्बिटल 2 इलेक्ट्रॉन. सोडियम group 1 third pair, so last orbital में 3s1. That's why ns1 to 2 the electronic configuration of s block elements or representative elements. In case of p block elements 13 to 17, p block means 13 to 18, but he distinguished the noble gases elements. Representative is S and P block, that is 13 to 17, only 5. So what will be this configuration of P block elements? 13A, 14A, 15A, 16A, 17A. 1, 2, 3, 4, 5. These 5 groups elements, that is the representative elements, that is the P block elements. Okay. इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या होगा? NS2 and NP1. This is NP2. This is NP3, NP4, NP5. That means NP1 to 5. 6 तो नहीं होगा, 18. क्यों? 18 जो है वो नोबल गैस. So इसका आउटर मोस्ट इलेक्ट्रॉन NS2, NP1, NP2, NP3, NP4, NP5. Okay? Then NS2 to NP1 to 5. So these two S block elements and P block elements togetherly called the representative elements and also called typical element. You can call also typical element. Okay? Then inner transition, then come transition elements. Okay, next transition elements. The transition elements, that is the which block? D block elements. Transition elements, D block elements. Okay. So what is the transition elements? इसका electronic configuration क्या होगा? NS1 minus 2 n minus 1 D 1 to 10. This is the electronic configuration of transition elements. It's the D block elements. NS1 to 2 n minus 1 D 1 to 10. That means D orbital में maximum 1 থেকে 10 থাকবে আর NSA 1 to 2. So suppose Y number 3 to number 12. This is the D block elements. What is the definition of transition elements? Why it is transition elements? You must remember that transition elements means ground state or excited state. The ground or excited state जिसका d orbital partially filled, d orbital, that is the transition elements. Ground state or oxidation state, anyone. That are half filled, no, that are partially filled d orbital. D orbital always be partially filled. That is the transition elements. What you see, any elements from here, scandium, titanium, vanadium, anything. And what is the scandium? Argon 3d1 4s2. 3d1 4s2. Okay. Vanadium, argon 3d2 4s2. This is the partial refill orbital. You observe, you must notice that copper, silver, gold, zinc, cadmium, mercury, these three elements, that is the 11th group and this is the 12th group elements, this and this. Sometimes questions may come, can zinc be called a transition elements or copper be called transition elements? But you see, copper, silver and gold, if you do the electronic configuration, copper, see out here, copper 29, the 29 का configuration क्या होगा? The shortcut configuration, short process, as method, argon, helium, neon, argon, krypton, xenon, radon. You should have to remember this atomic number, helium 2, neon 10, argon 18, 2, 10, 18, 36, 54, 86. You should have to remember this. Okay, 2, 8, 2, 10, 8, 36, 54, 86. Okay, this is the atomic number of the noble gases. If you take argon, that means 18 will be taken, 8 electrons are there. Then 18 are 10, 28 plus 1, 29. The argon 4s1, 3d10. The D block fulfilled. You cannot regard as these D block elements, that is the transition elements, that is not the partially filled. Of silver, gold also 5s1, 3d10, 6s1, 5d10, all are fully filled. But what is the definition I told? The ground state, this is the ground state. This is normally atomic state condition or oxidation state. Oxidation state means copper oxidation state, that means if this copper loss an electron, loss of electron, oxidation, gain of electron, reduction. But in oxidation state, copper loss on electron, that is in copper plus. That means from the outside, what is the electron configuration of copper plus? That means from the outside cell, that is the s orbital, one electron will be out. That is the 3d10. It is fulfilled. Then copper 2 plus oxidation state, copper N2, 3. That means last electron from the d orbital will go out, argon 3d9. So this is not the full fill or half fill, this is partially filled. So this can be regarded as the transition elements. Copper can be regarded as transition elements. But in case of zinc, cadmium, mercury, see what is the zinc atomic number? 30. The argon 4s2 3d10. Cadmium, krypton 5s2 3d10. This is also 6s2 3d10. All are fully filled. Okay, this is the ground state. Come to the oxidation state. Suppose zinc, oxidation state only 2. That means 2 electron will be out. So what will be the configuration? Argon. That is the last cell, S. 2 electron will be out. So 3d10. In case of zinc, the ground state also fully filled d orbitals, and oxidation state also fully filled d orbitals. So in this case, it cannot be regarded as a transition elements. Clear? And also this cadmium, also mercury cannot be regarded as transition elements. Okay? But copper maybe cannot. It is in the copper the oxidation state. It is not fully filled. Clear? Next come inert transition elements. Inert transition elements. See, inert transition elements, then noble gas elements. Inert transition elements, so that is the same thing. Inert transition elements. This is the inert transition elements. A block elements. Inert transition elements. Only what is the difference? NH2, N minus 2F. NH2, there is the inner transition, that is a block, that means there will be F. Nothing else, it will be wipe out NH2 clear N minus 2 as it is the F blocks elements. So there will be inner transition, inner F, the N minus 2 F, here F, N minus 2 F, 1 to 14, and N minus 1 D, 1 to 10. This is the general electronic configuration of what? Inner transition element. That is the inner transition element. Inner transition element. Inner transition element. Clear? This is the general configuration. In this configuration, third group elements. That is the out here. Third group elements. All are inner transition elements. Yes. Very good. Third group elements and sixth period, seventh period. These two periods are inner transition elements. That is from the lanthanum, that is the your actinium to lawrencium, lanthanum to lutetium. This is from cerium. We have already told just before out here 58 to 71. And from thorium 90 to 103, these are called the inner transition elements. In this case, what you actually find out, the seventh to the actinium which is D block elements. Actually, this is the D block elements. Starting is the lanthanum, which is the D block elements. Actinium also D block elements, but from this 71 and from this 89 and 90, this is the A block elements. In this, if you arrange the electrons configuration or electron configuration, you will find that there will be in this form all the elements come under this, and F is the inner. All the inner atom electron will enter in this inner F orbital. All this inner F1, F2, F3, F4, F5, F6, F7 up to F14 of electrons will enter in this inner F orbital. Okay, I will not in this way. Suppose this is nucleus, the last cell, NS2, this is D, this is F. In this orbital, electron enter. Next come the noble gases, the inert gas. Why there are noble gases? The last 18 elements, 18 group elements, helium, neon, argon, krypton, xenon, radon, all these are the inert gas elements. What we see in each and every element, helium 2, 10, if you configuration, that is the, in this case of electronic configuration of these elements, what you see, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4p6, 5s2, 5p6, as a, okay, 6s2, 6p6, okay, that means 4s2, 2p6, that means ki radium 6s2, 6p6, that means outermost cells are full of octet. They neither lost, that means 1s2 helium, 2s2, 2p6, 3s2, 3p6. All orbitals are fulfilled, 6 and 2. 8 elements are there. All are stable, all are octet, stable, inert. They neither lost nor gain electron. So they are inert. Normally, not easily, they lost electron or gain electron. That's why they are stable configuration, and they are stable, they are inert in nature. Okay? All these elements are categorized according to the scientist board. Representative elements, S and P block, transition elements, inner transition elements, and noble gas elements. Okay, these are the total categories of the classification of the elements according to the board. Okay, thank you. Now I will discuss the topic lanthanide contraction. Lanthanide contraction. Lanthanide contraction means what? And what is the cause of the construction of lanthanide? Contraction, संकोचन, lanthanide संकोचन. And the संकोचन क्या है? Q, what you see from, if you go from, that is the atomic number lanthanide group out there, cerium to deuterium, that is 58 to 71. If you go, what you see, the atomic radii structure, what you see, suppose it is the cerium 71, this is the nucleus. It will gradually, size of the atom gradually decrease. '71, '72, '73, '74. Okay. As it. This is the 50. No, sorry, 58. Sorry. 58. I have not acknowledged. That is the 58. This one 58. Here 59, 60, 61, as 71. Okay. Here this is the. If we go in this way, we see the atomic radius is being small, gradually smaller. The attraction is higher, nuclear charge is higher. So what is this? In here, the size, that is the atomic size or ionic size or atomic radius, gradually becomes small from left to right. From left to right, atomic radius, ionic size of the atom gradually small from left to right. Okay? From cerium to deuterium. From this lanthanides group. That is the lanthanide contraction. Why? This contraction of this atomic size. This is known as the lanthanide contraction, lanthanide संकोचन. What is the cause? What is the cause of the lanthanide contraction? And the electronic configuration of this element I have just earlier discussed. The general electronic configuration for 6s2 here, 6s2, F12, F1 to 14 and 5d 0 to 1. Here 6s2, what is C? 6s2, 4f1 to 14 and 3d 1 to 10. 3d 1 to 10. No. Any one of you? 0 to 1. Here or not? 3d 0 to 1, 4f1 to 14 and 6s2. It is the natural or general electronic configuration. Here, but what is the cause? Main cause of the electronic configuration, that is fill first orbital, last electron fill into F subset. Whatever the electron added in the nucleus, suppose this is the nucleus, electron are added progressively. Suppose this is 6s2, which is 3d, which is 4f. All the electrons are added, same group, electron added in the same cell, in the same outermost cell, that is the f orbital. That is the contraction of the side of the atomic size, adding the electron, okay, in the same orbital, f orbital. This is the inner orbital. Suppose there is electron, some electron, here is also electron, here is electron, here is also electron, last cell. In this case, you must remember one thing, the shielding effect or screening effect. Shielding effect or screening effect. This is very important. And effective nuclear charge. The shielding effect or screening effect, which I have discovered in the atomic structure and which we will discuss in another chapter also. The shielding effect and the effective nuclear charge, it is the main cause of the contraction of this group. This is a lanthanide contraction. Number of electrons added and number of electrons is increasing, but electron is added in the same f orbital. Electrons of inner subcell resist the outer electron. Electron of the inner subcell. In inner subcell, electron is resist the outer electron out here. The resistance power, this is S. S subcell resistance power is greater than this, and the outermost electron, it is the attraction of the nucleus to the last electron, attraction, and all of the electron is being resisted. Suppose give an example. Suppose there is a table fan, it is moving, all are sitting here, you and you and you and you are there. Who is sitting out here? He gets the air blow too much. Third man is there, a little bit, where in the frame who is sitting away from here, that means this air is being resisted by this, and a little bit is coming out here. And this fans, this is acting as the screening or shielding effect. So these electrons acts as a shielding effect, which resist outer electron. The inner subcell resists the outer electron. Inner electron resists the outer electron. That is, the charge of nucleus increase and shielding effect is less towards the last cell. Shielding effect is less towards the last cell. That is opposite 6s. Clear? And the attract and nucleus attract towards itself and size being smaller. Size being smaller. In this way, lanthanide contraction happens. Okay? So, this is the lanthanide contraction, and same case happens in the actinides also. That is known as the actinide contraction. So, this is the concept of lanthanide contraction. Okay? Okay, the last topic, which I also discussed, continue. I also discussed, this is the last topic, today's discussion. I have already discussed sister classes. You have to find out the elements of periodic table, in which group each, which periods, which blocks, any one of the elements among the periodic tables. You have to find out. You do not require to remember which group it belongs and it is situated. Okay. See, we have to first, yesterday I have told S block, P block, D block elements and how to find out the position of electron in periodic table. This is the just revised class. Position of electron, position of element in periodic table. Suppose, let's see nitrogen. You should have to remember the atomic number I told you. 1 to 20 is must, plus 9 and 10 you have remembered, plus 1 to 30 up to 50. If you remember the atomic number, then it will be clear. Okay, nitrogen 7. Okay, let's find out the period. You have to find out the period, block and group. Yesterday I have told in yesterday's class, period means highest value of principal quantum number of the valence electron. This is the group. That is the last cell, is denotes the period. And last electron, that is the valence electron. Last electron exists in which subcell? The subcell of last electron. That is the block. And group. In case of group, you have to a little bit change. In case of 9 and 10, I have this. You can easily find out the group and the 3. So 3s1, third period, first group. But here a little bit difference. sp block. S block element के लिए क्या होगा group? P block element के क्या होगा? D block के क्या होगा? A block के क्या होगा? Okay. Nothing else. The highest period means highest block. Suppose an example I am giving. So given a little bit. Suppose actually elements A. इसका एलिमेंट 16, ओके 16. तो 16 जो है you have to इलेक्ट्रॉनिक कॉन्फ़िगरेशन बोलो 1s2 2s2 2p6 1s 2s 2p6 6 to 8 to 10 3s2 कितना होगा 2 to 4 4 6 10 to 12. Then what will the value of P? Tell me. 3 or 4? 3 to 4. क्या? 3 16. 16 का मतलब क्या है? 2 to 4 6 4 10 12 और 4 16. 4 to 6 6 12 14 16. The last electron goes to the highest number of cell 3. Then the electron last electron in 3p subcell. 3p subcell, that is the third period. Third period, that is the period number 3, the third period. Block number P block element clear, and group number will be, that is the P block elements के लिए group number क्या होगा 10 plus total number of valence electron. 10 plus total number of valence electron. The valence electron कितना 4 plus 6 2 6 10 plus 6 16. This is a 16 group. A 16 group and third period, that is the third period 16 group. Clear? Okay. That is the sulfur. Clear? This is the sulfur. You can calculate it as it is 10 plus 10 means what? This is the D block. Well, S block plus D block plus last electron. Same thing देखो. well, S block में कितना है? 2. 2 plus 10 D. S plus D block plus last electron in the last orbital P में कितना होगा? 4. ऐसे you can write. 10 plus 6, that is the valence electron or total number of valence electron, or 2 S subcell, D block, S block, P block, that is the also 16. In this way, you can calculate the period, block and group. Suppose 30. An element which is 30. You know what is 30? Copper 29. Copper अभी हम लोग copper 29. Zinc 30. तो जिंक का क्लासिफिकेशन क्या होगा? 1:2, 2:2, 3:2 को ऐसे लास्ट सेल 30 में क्या होगा? 3D last cells 1:2, 2:2. If you configure it, the period will be 30 means 1:2, 2:2, 2p6, 2p6, 3:2, 3p6, 4:2, and 3d6. Okay, 3d6, 4:2. Last day 4:2, 3d6. Last cell, ultimate principal quantum number, highest number value is 4, which is the fourth fluid element. Last electron, which orbital? The d block. And group, which groups? 2 plus 6. No, 2 plus which? 10. That is the 12. The 12 groups. Okay, d blocks and fourth period the element situated. Clear? Okay, thank you. So I see it is clear. So I hope all these discussions and this topic up to this will be crystal clear to all of you. If not, go to my box, description box. Link is given and see and observe. If any doubt, if any queries, ask me in my comment box. I will give you reply. Okay, in the next sessions. Thank you. So stay safe, stay happy life. Okay, good night.